Hi everyone, how are you all? I hope you are good. So today we will be solving the question transpose matrix. I think all of you are aware of the word transpose, that what does it means? Transpose basically means interchanging the values of those two columns and vice versa. So let's see what is this question saying. Given a 2D integer array matrix, return the transpose of a matrix. We are given within 2D integer array and we just need to return its transpose matrix. Okay, let's see what is the definition of a transpose. The transpose of a matrix is the matrix flipped over its main diagonal, switching the matrix row and column indices. What basically a transpose of a matrix is, we just need to flip the values over the main diagonal. Let's see here. It is the diagonal values are 2, 5, and 6. These will remain as it is in the transpose matrix. And the values over its diagonal and below its diagonal will be switched. Like 4 will be swapped with -10, -1 will be swapped with 18, and so on. Okay. So we just need to return the transpose of a matrix. So you can see that in our transpose matrix, the number of rows and columns will be interchanged. Like let's say in this example, the number of rows are also 3 and columns are also 3. So in the transpose matrix, the number of rows and columns will remain same. But if we see this example, in this the number of rows is 2 and the number of columns is 3. Let's see this example so that we can get the better idea of transpose of a matrix. Okay, so see, we are given the 2 rows and 3 columns. Okay, so it consists of values 0, 1, 2, 3, and 4, 5, 6. So this is 0th index, this is 1 index, this is 0, this is 1, and this is 2. Okay, so we need to return its transpose matrix. So you can see that the number of columns in this matrix will be the number of rows in the transpose matrix. Okay, because we need to interchange the values. The values at the row will become the values at the column, and vice versa. Or we can say like the values at the column will become the values at the row. So in short, we can also say that as it has 3 columns, so in this we have 3 rows. The number of rows and columns will also get interchanged. Okay, so keep in mind that. Okay, so let's see. So what you can see that how we can find its transpose. So first of all, we can simply create a dummy matrix, let's say of size, because we know the size of this matrix, 2 rows and 3 columns. So we can create a dummy matrix of size 3 rows and 2 columns. Okay. So now after simply iterating this, if we are at 0, comma 0, we will simply update its value to 1. Okay. And now we will iterate and come at 2, 0, comma 1. So let's see. Here the indexing is 0, 1, and 2. And here it is 0 and 1. Okay. So here the value of at 0, 1 is 2. Now we will update the value at 1, comma 0 as 2. Here the value at 0, comma 2 is 3. Now we will update the value at 2, comma 0. So in this way we can find the transpose of a matrix by updating the values. We will as 0, the value at 0th row and 1th column is 2. So in the transpose matrix the value at 1th row and 0th column will be 2. Okay, I think you got that idea. So now let's try to code this. Okay. So first of all, we can simply store the size of the matrix, matrix dot size, and it will be the number of rows and will be the number of columns. So now we will create a dummy matrix result with m number of rows and n number of columns. Okay. because the number of rows and columns will also get interchanged. We can simply initialize it with a dummy value like 0, or if you don't want, then you can skip that as well. So now we will simply iterate over the matrix by running two nested loops. Okay, so now the value at ith row and jth column will be updated at jth row and ith column in our result. As you can see from here, the value at ith row and jth column will be updated at jth row and ith column. Okay, so in this way, we can find our transpose in the result matrix. So let's try run this. Yeah, it's working fine. Let's try submitting this. Yeah, cool. So now let's talk about its time and space complexity. So as you can see, we are just running two nested loops for iterating the matrix. So its complexity will be big O of n into m. And now talk about its space complexity. If we consider the space of this result vector, then its complexity will be big O of n into m. Otherwise, we are not using any extra space for solving this question, so we can skip that as well. So its complexity will be big O of 1. Otherwise, we can also write its complexity as big O of n into m because we are using it to store our result. Okay, so I hope you get this question. It was a very easy question, and it is also asked in various interviews as a warm-up question as well. I hope you get this. Thank you for watching this video, guys. Bye bye. See you soon with the next video.